Hey, what's going on, everyone? Today, we're going to go through Code Review Lab and take a look at another challenge called food delivery. The description reads, review code for a food delivery platform's REST API built with PHP. The mobile app recently added a feature to display restaurant menus and details. Multiple customers have reported seeing unfamiliar order information when viewing restaurant pages. Investigate the API endpoints that serve restaurant data to identify potential information leakage. So let's go through this PHP code and see if we can find where that vulnerability is. Okay, so let's take a look at database.php. And this script looks pretty simple. It's creating a database class that has a public method called getConnection that sets up a PDO connection to MySQL. PDO stands for PHP Data Objects. And it's going to pass in the properties above in here as the localhost. The DB name will be food delivery, and then finally our credentials. And it's inside of a try catch block. So let's try and establish this database connection to MySQL using this data. If we run into an issue though, we'll throw this PDO exception and say there's a connection error and log that error. But if all goes well, we can return this connection string and use this as a means of communicating to the database. So that is database.php. Let's take a look at auth.php now. This is going to go ahead and require that database.php file we were looking at. Creates a class named auth middleware. It sets up a constructor function that's going to set up a database object for us. And in here, it's saying, hey, database equal new database. So we instantiated this new database object, and now we want to call that getConnection method that we just saw right here. And then we're going to store that in this DB. And then this will give us the ability to perform our SQL queries. So as you can see down here, this DB, prepare, select, and we'll get to this in a second. But just establishing what this DB is doing. Line 12, we have this authenticate method. And inside of this, we're setting up two variables, headers and token. Headers is storing a built-in PHP function, so that is get all headers. So that's going to return all of the headers and then store that inside of headers. And then it's going to do another PHP built-in function check called isSet. So it wants to check the authorization header to make sure it's set and not null. But if it is null, we're going to return false. But if we're good and it is set, we can then perform this SQL query here. So select user ID email from sessions where token equals, and then we have this question mark for a placeholder, and expires greater than now, which is a built-in MySQL function. And this question mark is a placeholder for token. And if you're not familiar with this, this is performing a parameterized query. This is how PHP can perform database queries to avoid SQL injection attacks. So this is what a parameterized query looks like in PHP. We then want to execute this and then fetch that data and store it inside of this session variable, and then return this session variable. Next, let's take a look at restaurants.php. Again, we're making a call to require that database.php file, creating a constructor function here that's going to set up a database object for us and allow us to perform queries against the database. So this DB prepare, so what query do I want to run? Select all from restaurants where ID equals, and the placeholder will be for restaurant ID. So select all from restaurants where ID equals to restaurant ID, and then fetch that data, store that in this restaurant variable, which is of type array. And then the next block is another SQL statement that says select all from orders where the restaurant is the restaurant ID. So pulling from two different tables, this one is going to fetch all the data and store that in orders. And then we're going to append to the restaurant the orders data that we get back, and then return the restaurant. So it's going to return everything that we abstracted from these two queries. Now, as I'm reading this, I notice this line is a little sketchy. The reason being is select all from orders where restaurant ID equals. And I would imagine what we would want to say is where restaurant ID equals and then a placeholder, but then append and where user ID equals, and then a placeholder, and then provide a value for like a user ID. Because this would cause the API to divulge all of the orders based off of just a restaurant ID. And that could lead to seeing everybody's orders if they're navigating to this API endpoint. So whatever information that could be, it could be pretty sensitive. So let's put a pin in this one. Let's come back to this in a little bit. Let's check out order.php. In order.php, it looks like it's another function or another class named order. Here's our properties. The constructor function looks a little different than what I'm used to from these past couple examples, and this passes in a DB, but let's keep moving through this because I'm curious about this method create, because this is inserting into the orders table, which we just saw, a user ID, a restaurant ID, items, total amount, delivery address, phone, and status. And then here's the values that are actually going to be stored in the database table. And then down here, we're binding these values. So again, this is a means of parameterized queries in PHP so that we can try and prevent SQL injection attacks. And that safely passes that data in. But the more I'm seeing this, so there is a user ID for orders. I would imagine what that means is there's some sort of users table that could be in relationship to orders. So a user can have many orders, for example, and if we're divulging all of the information from orders from the previous file, that would mean delivery address and phone could be divulged in that API response. So that was select all orders from based off just a restaurant ID. So that would be delivery address and phone number, which I know if my data like that was being exposed in an API, I'd be a little uncomfortable with that. But there is a user ID, which I would imagine that means that there's a relationship between like a users or a customer table that this should also be pulling from. So that's a little suspicious in my eyes. Let's take a look at index.php. This is requiring the database auth and restaurants.php file, just not the order.php. The content type will be of type JSON. And then we're creating this auth object in here and then calling that authenticate method right here. And then we want to check if the user is authorized. And if they're not, we're going to return a 401 unauthorized in JSON data. But if they are, then we're going to say they can request the URI and a request method. So the request that we send over will do, let's see, a regular expression match on the API restaurants, and then what's the request URI that matches, and then this is based off the restaurant ID. We're going to create a new API object. So new restaurant API, run this API right here. Then we'll call the get restaurant details method right there, pass in that restaurant ID, which so that does get passed in there, and then return the results as JSON. But if the ID does not exist, we return a 404 and say the endpoint is not found. So that is interesting. I am leaning towards this being the vulnerable line of code. I don't think this query is complete, and I think because of that, it's divulging too much information to the users. And based off of that, I'm going to go ahead and select line 17, and let's just see if I'm right about this. So submit solution, challenge complete. Okay, so that was it. I was a little nervous about that one. I'm not going to lie. Understanding the vulnerability. So this application has a critical information disclosure vulnerability in the restaurant details API endpoint. The vulnerability exists in its API / restaurant.php, where the get restaurant details function retrieves restaurant information along with all orders associated with the restaurant regardless of which user is making the request. The problem code fetches orders using only the restaurant ID. Yeah, as the filter without checking if those orders belong to the authenticated user. Right. So yeah, the order should be in relation to the particular customer or the user, not just by restaurant ID. Oops, scrolling the wrong way. This means any authenticated user can view complete order histories from other customers, including their addresses, phone numbers, content, all this sensitive information. So I thought that was a pretty fun challenge. I hope you enjoyed this. If you were following along, I hope you learned a thing or two. I hope you found some value in this. Let me know if you want to see more Code Review Lab challenges just like this. I'm always happy to make them. Have a wonderful day and happy hacking.